We all feel time. It moves forward. It never stops. It turns childhood into adulthood. It turns today into yesterday. Time feels so real that questioning it sounds absurd, and yet some of the deepest theories in physics suggest something shocking. Time might not exist at all, not in the way we think it does. To understand why, we need to start with something simple, something obvious, something we never question: change. We experience the world as a sequence of events. One thing happens, then another, then another. A ball falls, a heart beats, a thought appears, a moment passes. This sequence feels natural, so natural that we assume time is what causes it. But physics tells a different story. In classical physics, time is treated as a background, an invisible stage where everything happens. It flows at the same rate for everyone, everywhere. This idea comes from Isaac Newton. To him, time was absolute. It ticked forward uniformly, whether the universe existed or not. And for centuries, this worked perfectly, until it didn't. In the early 20th century, Albert Einstein shattered this idea completely. He discovered that time is not universal. It is not fixed. It is not the same for everyone. Time depends on motion. Time depends on gravity. If you move fast enough, time slows down. If you are close to a massive object, time slows down. Two people can experience different amounts of time between the same events. This is not philosophy. This has been measured. Atomic clocks on satellites tick at different speeds than clocks on Earth. So time is already strange. But Einstein's theories reveal something even more disturbing. They suggest that the universe does not evolve moment by moment. Instead, all moments may exist at once. Past, present, future, all equally real. This idea is known as the block universe. Imagine the universe not as a movie playing frame by frame, but as a single frozen structure. Like a book, every page exists simultaneously. You experience the story by turning the pages, but the pages themselves do not appear or disappear. In this view, time does not flow. Nothing moves from past to future. You only experience one slice of a four-dimensional structure. This immediately raises a terrifying question. If all moments already exist, why does it feel like time is passing? Why does the present feel special? Physics offers no clear answer, because in the equations, there is no now. There is no arrow pointing forward, no built-in direction, no privileged moment called the present. The laws of physics work just as well forward as backward. A broken glass shattering looks different from a glass reassembling itself, but at the fundamental level, the equations allow both. So where does the arrow of time come from? Why do we remember the past, but not the future? Why does entropy increase? Why does experience feel like a flow? This is where things get uncomfortable. Because one possible answer is that time is not fundamental at all. It may be something that emerges, like temperature, like pressure, like waves in the ocean, real at our scale, but not real at the deepest level of reality. And if that's true, then time, as we experience it, may be more like a shadow than a thing, a consequence of something deeper, something timeless. And this is where the real problem begins. Because if time is not fundamental, then neither is change. And if change is not fundamental, then the universe, at its core, may be completely static. No flow, no passage, no becoming, just being. So why does anything happen at all? That question leads us directly into the most radical ideas in modern physics, and this is where time doesn't just bend, it starts to disappear. To understand why time might not exist, we need to look at the two most successful theories in physics: general relativity and quantum mechanics. Both work incredibly well, and they completely disagree about time. In Einstein's general relativity, time is flexible, it bends, it stretches, it slows down near massive objects, but it still exists. It's woven together with space into something called space-time. In quantum mechanics, however, something strange happens. Time behaves differently. It is not treated like space. It is not an observable. It is not something you can measure directly in the same way. And when physicists try to combine quantum mechanics with general relativity, time breaks, literally. When researchers write down the equations for a quantum theory of gravity, time disappears from them entirely. There is no variable for time, no ticking clock, no before, no after. The most famous example is the Wheeler-DeWitt equation. It describes the quantum state of the entire universe, and it has no time in it. This is known as the problem of time. At the deepest level, we know how to describe reality. Nothing evolves. Nothing changes. The universe just is. This sounds impossible. After all, things clearly happen. Stars explode. Particles collide. You are listening to this right now. So how can a timeless universe produce a world full of change? The answer many physicists give is unsettling. Change is not fundamental. It is relational. Instead of saying, "This happens at time t," physics may only describe relationships between states, one configuration compared to another, one correlation compared to another. Time, in this view, is something we infer, not something that exists on its own, like pages in a book that don't move, but feel like they do when read in order. This leads to an even stranger idea. Maybe the universe is fundamentally frozen. All possible configurations exist, all states are there, and what we experience as time is just our consciousness moving through them, not because time flows, but because memory exists. Think about it. The present feels real because it contains records of the past, memories, traces, evidence. You remember yesterday. You do not remember tomorrow. That asymmetry creates the illusion of flow, but the laws themselves do not care. At the quantum level, particles do not know which direction time points. Processes are reversible, cause and effect blur. Some physicists even argue that the universe does not evolve forward. It simply contains correlations that give the impression of evolution. In this picture, the universe is not a story being written. It is a complete book, already finished. And you are not moving through time. You are a path through a static structure. This idea deeply disturbs many scientists because it challenges something fundamental about identity. If all moments exist, then every version of you exists too. The child you were, the person you are, the person you will become, all equally real. There is no privileged now, no special present, no moment where reality truly happens. And if that's true, then the feeling that time is passing may be a feature of the mind, not the universe. But this creates a new problem. If time is an illusion, why does it feel so powerful? Why does it hurt? Why does it heal? Why does it seem unstoppable? To answer that, we need to talk about entropy, information, and why the universe remembers the past but not the future. And that takes us to the final and most unsettling part of this story. If time does not fundamentally exist, then why does it feel so real? Why does it hurt to lose someone? Why does waiting feel unbearable? Why does the past feel fixed and the future uncertain? The answer most physicists point to is entropy. Entropy is a measure of disorder, and it always increases. This simple fact creates what we call the arrow of time, not because time flows, but because disorder grows. A glass can shatter, but it never spontaneously reassembles. Smoke spreads, but it never gathers back into a cigarette. Your body ages, it does not unage. This is why the past feels different from the future. The past has lower entropy, the future has higher entropy, and your brain is built to record states of lower entropy. You remember the past because traces exist, photos, memories, records. You do not remember the future because those traces do not exist yet. Not because time flows forward, but because information only accumulates in one direction. In this view, time is not something the universe does. Time is something we experience, a consequence of being information processing systems inside a universe where entropy increases. Your sense of now is not a universal feature, it is a local illusion. This idea has shocking implications. If time is emergent, then it is not fundamental to reality, just like temperature. Temperature feels real, hot and cold feel undeniable, but temperature does not exist at the level of individual particles. It emerges from motion and statistics. Time may be the same, real to us, absent at the deepest level. This forces us to rethink what existence even means. We usually imagine the universe as something happening, but what if the universe simply exists and experience is something layered on top? What if the universe is static and consciousness is what gives it motion? This does not mean your life is meaningless. In fact, it might mean the opposite. If every moment exists, then every moment matters, not because it passes, but because it is. The love you felt, the fear, the curiosity, the wonder, they are not fleeting, they are permanent features of reality. You are not racing against time, you are a pattern inside it, or maybe outside it entirely. So when physicists say time might not exist, they are not saying nothing matters, they are saying something far stranger, that the universe is deeper, colder, and more alien than intuition allows, that reality does not revolve around human experience, and that what feels most fundamental to us may be a beautiful illusion. So the next time you feel time slipping away, remember this: it may not be running out, it may not be moving at all, it may simply be waiting.